Okay, good morning, afternoon, evening. I don't know what the time is wherever you are, but this is video 7, Algebra, Collecting Like Terms and Algebraic Conventions, which sounds a little bit complicated, but it isn't so bad. What is the difference between these two? If I have the A, add A, add A, think of them as things. So, I don't know, for example, apple. An apple, add another apple is 3 apples. Okay? So that's 3A. Nice and simple, 3A. Now, when you multiply, this is something slightly different. Now, think of it in these terms. If it was 2 times 2 times 2, you would know that, well, some of you are going to rush in and say 6, and that's not right. It's not 6. 2 times 2 is 4. 4 times another 2 is 8. Now, another way of me writing 2 times 2 times 2 is 2 cubed. So 2 cubed is equal to 8. Now, I'm going to put that in a bubble because obviously ours involves algebra, not numbers. So if I've got A times A times A, in the same way I can collect these terms together to make 2 cubed, you can collect these 3 A's together to give you A cubed. And that's your answer to that one. Now, the next slide, 2A, add 2A, add 2A. Well, 2 apples, add another 2 apples, add another 2 apples is 6 apples, so 6A. And again, 2A times 2A times 2A, well, you can multiply the numbers together. I'll just underline each of the numbers. 2 times 2 times 2 is going to give me 8. And A times A times A, you'll remember from the previous example, is A cubed. And that's the answer. The thing about algebra, which initially some students find difficult to comprehend, is you leave the letter in your answer. So, some people will think, oh, there's a letter at the end, I must have done something wrong. That is correct. So you can't get rid of the letter because you're being asked to collect them together. You're being asked to simplify it. So 2 times 2 times 2 is A. A times A times A is A cubed. When you're writing a letter times a number, you just write them next to each other. So 8 times A cubed. Okay? So if you prefer, you may think of it as 2 times 2 times 2 times by A times A times A. Okay? So that's 8 times A cubed, which is 8A cubed. So when you're adding and subtracting terms, as already shown, if I had 3E plus 4E plus 7E take away 2E. Now, the first thing you need to ask yourself is, are all your terms consistent? And in this case, they are. The algebraic terms, the letter, the unknown, is the same letter, which means you can collect all of these together. Okay? There's no F's or G's or H's. There's no E squareds or anything complicated. It's just E's all the way through. So, 3, I don't know, consider them something beginning with E, eggs. 3 eggs, add 4 eggs, add 7 eggs, take away 2 eggs. How many eggs are you left with? So 3 add 4 is 7, add another 7, 14, take away 2. My answer is 12E, 12 eggs. Okay? Now let's take a look at an example where you've got 2 different terms, okay? So a second example, I'll call it EX2, sorry, example 2. If I had 3J plus 6K minus 2J plus 5K. So in this case, they're not all the same letters. So you can't collect all of them together. My answer is going to have 2 terms in it. There's going to be some J's and there's going to be some K's in my final answer. So let's deal with each of those separately. If I just put a circle around the terms that have J, and remember the minus stays with the term. So, stays with the unknown. So minus 2J, that's one term. 3J, take away 2J, is 1J. So I can write 1j. And then I'll put a square around the terms that involve a k. So I've got 6k, that's a positive 6k, plus another 5k. So 6k add 5k is 11k. And that's your answer. The only thing you may want to note down here is, if you've got 1 of anything, you don't have to write the 1. So I could just write this as j add 11k. Because if it's 1j on its own, that's the same as that. 1j on its own is just j. Okay? So this is called collecting terms, and I've collected the like terms. The j's go together, the k's go together. Okay, so if you want to pause the video and have a go at this one now yourself. 3m plus 6n take away 5m take away 2n. Pause the video now. (3m) take away 5m. Well, 3 take away 5 is -2 or -2. Minus 2m. 6n take away 2n is 4n. Some of you will maybe think that this should be a negative, but you've got to remember that positive 6 take away 2 is positive 4. Okay? So if it helps, maybe think of a number line. 6, move 2 to the left. Yeah, if I'm taking away 2, that gives me positive 4, not negative 4. So that would be my answer to that. Now, you don't collect this any further. Some people may be tempted now to collect that together and make, I don't know, 2mn or something. You're not allowed to mix these letters together. When it's adding or subtracting, you don't mix the letters together. So that's your final answer. This time, slightly complicated looking, but it's the same basic principle. So if I had a squared plus 3a squared plus 7a squared. Now, again, you ask yourself, are my terms consistent? So a squared is the unknown. So that means you bring together all the a squareds. So I've got a squared, remember when it's on its own, that's 1. So 1a squared plus 3a squared, so that's 4 so far, plus another 7a squared gives me 11a squared. Okay? And that is that answer. Here is an example where I've mixed up x squareds and x's. Now, a common mistake again is that people may think because there's x in both, you're allowed to mix them together, and that is not the case. Just because there's x's in both doesn't mean they're the same terms. X squared can be collected with the other x squared. Normal x's on their own can collect with any other normal x's on their own. So you collect these together. 3x squared take away x squared is 2x squared. 2x plus 7x is 9x. And that is the answer to this question. You can't collect those two together. I can't make that, for example, some people might say, oh, that's 11x cubed, for example. And that is wrong, okay? You can't collect the x squared and the x together because it's got an add in between. If it's an add or a take away, you can't bring those together because the terms are different. That's an x squared, that's a normal x. 4y cubed plus 3y take away 2y cubed take away 12y. Pause the video now and have a go at that question yourself. Is an exam questions booklet taken from a website called Maths Genie, and we'll start with the first set of questions and see how we go. So, the first set of questions, if you can see them there, say C add C add C add C. I'm looking at this one here, 1i. So that's, I don't know, cats, for example. One cat, add another one, add another one, add another one. That is 4 cats, 4c. Remember what I said about multiplying. P times P times P times P. That would be P to the power of 4. Because you're timesing them together. So you use what's called index numbers. 3 G's, giraffes, let's say. 3 giraffes, add 5 more giraffes. I've now got 8 G's, 8 giraffes. And finally, 2R times 5P. So you can multiply the numbers together. 2 times 5 is 10. R times P is RP. So you just write the letters next to each other. When you're multiplying, you are allowed to bring them together. When you're adding or subtracting, then you don't, if they're different letters, that is, then you don't bring them together. Because these were the same, G's add G's, then I can just bring them together. So I'm looking at question 5. Question 5 says, 5a, 2x times y times 3. Now, again, you're timesing, okay? So we are going to end up with one collected term. X times y, that's just going to be xy. You just write that next to each other. 2 times 3 is 6. So it's 6xy. That's the answer to that question. Now looking at part B. 5x plus 3y, take away 2x, plus, when it's on its own, remember that's 1y. So that's a 1y. Okay? Now I'm going to put circles around the x's. And I'm going to put squares around the y's. So 5x take away 2x is 3x. 3y plus 1y is 4y. 3x plus 4y. Now once again, if you were in front of me, I'd be asking you, why can I not simplify that any further? Why can't I say that's 7xy? The answer is because they are different letters, different terms, and because I'm adding, not timesing. If it was timesing, like the question above, then you just write it next to each other, x, y, like that. But this is not a times sign, this is an add sign, so you leave them separate. Last question of question 5, y times y times y. That is y cubed. So please try these 4 and then these 3 questions here. I will ask you now please to pause the video. I was about to say I'll give you 5 minutes, but obviously I can't give you 5 minutes because you're not here. So please pause the video and have a go. When you're ready to see the answers, press play. Please pause the video now and have a go. One of the other features of algebra is its use when solving problems where there are unknowns. So, for example, if I tell you that I am 7 times the age of my daughter plus 8, okay, that's how many years old I am. So, let's say my daughter's age is X. I am 7 times her age. So, if I just put X as daughter's age, and I am 7 times her age plus 8. So the question would say, write an expression for my age. Write an expression for Mr. Sheikh's age. Now, if I told you that I'm 7 times older than her, plus 8, then the expression basically means an algebraic statement. I'll just write that. Algebraic statement. An expression for my age would be 7 times x plus 8. Okay? Now, we can simplify this because 7 times x, you should know, you can write as 7x. So 7x plus 8 equals Mr. Sheikh's age. Okay? That is an example of using the algebra, the unknown, to create, in this case, an expression. Now, I could make this slightly more interesting by saying, I don't know, for example, if I said that I was, I don't know, 50, how old do I want to be? 57. So let's say I was 57 years old. Then I know that 7x plus 8 equals 57. And this is called an equation. Okay, this is called an equation. An equation is an expression that has an equal sign on it, an equals with a number. So in this case, 7x plus 8, I know Mr. Sheikh's 57 years old, so 7x plus 8 must equal 57. Now to solve that, I would take away 8 from both sides. This is called solving equations. 7x equals 49. And then I divide by 7 to say that x equals 7. So what I've just worked out is the original number I started with, which was my daughter's age in this example, is 7. Okay, so you start with an unknown, you use that to form an expression, and then if the question, so that might be, for example, part A, write an expression for it, and then part B will say, Mr. Sheikh is 57 years old. How old is his daughter? So my daughter is 7. If I'm 57, she has to be 7.